Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the Semester 1 Algebra 2 Honors Final Exam Review. Alright, let's take a look at question number 16. It reads, what is the solution set of y squared minus 2y less than or equal to 3y plus 14? So this is a quadratic inequality type problem. Let's take a look at the steps to guide us through the problem solving process. So first thing we're going to do is rewrite in standard form. After doing that, we're going to find the critical values. Now, after you find the critical values, there are two methods that can be used to solve the problem. One is easier than the other. One method involves using a sign chart to test intervals for which one satisfies the inequality, and the other involves using a graph. Okay, so for step 3, you use chart. Let's call it sign chart. You use the sign chart or graph to solve. Okay, I will show you how to use both methods. Now let's get started by rewriting the inequality, the quadratic inequality, in standard form. So all I'm just going to do is set it equal to 0. Less than or equal to 0 with the terms in descending order of degrees. Okay, I said less than or equal to because I have the squared term on the left side and I have a less than or equal to symbol here. The goal for expressing it in standard form involves placing all the terms on one side in descending order of degrees and having 0 on the other side. So let's go ahead and do that. We'll just simply subtract 3y from both sides and subtract 14. So subtract 3y, subtract 14. That will give us the standard form, which is y squared. Combine these two, you have negative minus 5y minus 14 less than or equal to 0. Okay, so it's kind of in standard form right now. So we're done with step 1. So what we're going to do now is find the critical values. Okay, now to find the critical values, we just have to find what makes this quadratic expression on the left equal to 0. Okay, so let's do that. We're going to find the critical values. So all we just have to do is take y squared minus 5y minus 14 and set it equal to 0. Okay, so we're going to solve this by using the x game. We have a quadratic trinomial here. AC is negative 14 and b is negative 5. The two numbers that work here are negative 7 and 2 because these two multiply to give you negative 14 and not to give you negative 5. Now in this scenario, a is equal to 1, which is good, so no need to factor by grouping. Okay, we can jump directly to the factored state. Alright, so let's do that. The factored state is going to be y minus 7 times y plus 2. Now to finish this up, we'll use the zero product property and set both factors equal to 0. And then when you solve this by adding 7 to both sides, you have y equals 7. When you solve this by subtracting 2 from both sides, you have y equals negative 2. Okay, So those are your critical values. All right, we're now done with steps 1 and 2. So final step is to use either the sign chart or the graph to solve the problem. Okay. Now I'm going to divvy up my work into two parts. I'll do the sign chart, which is a longer process on the left, and then I'll do the sign chart, the graph on the right. Okay. So method 1. Method 1, we're going to use a sign chart. All right. Okay, so what we'll do here is just simply make a number line and graph our critical values. Our critical values in ascending order, they are -2 and 7. Okay, so this can enable me to divide my regions into 3 intervals. Okay, interval 1 is to the left, interval 2 is going to be in between, and interval 3 to the right. So we have interval 1 here, interval 2, and interval 3. Now what we're going to do is pick numbers in each interval that satisfies the inequality. Okay, so to the left of -2, let's pick a number that's easy to work with. We can use x equals -3. In between these two values, we can use x equals 0. And then to the right of 7, we can use x equals 8. Okay? Now let's go ahead and carry out our test. We're going to be plugging it into the quadratic inequality in standard form. Okay, so let's test them. This is what we're testing. Y squared minus 5y minus 14 less than or equal to 0. So for interval 1, we're using, what are we using here? X equals -3. So what we'll do is plug it into this quadratic inequality and see if we end up with a true or false statement. Okay, so let's do it. We'll have -3 squared minus 5 times -3 minus 14. Is it less than or equal to 0? Let's simplify it using order of operations. -3 squared is 9 plus 15 minus 14. Is that less than or equal to 0? 9 plus 15 is 24. Minus 14, is that less than or equal to 0? 24 minus 14 is 10. Is 10 less than or equal to 0? The answer is no. 10 is greater than 0, so this is no good. Alright, this is a false statement. So interval 1 does not work. Okay, now this is how the solutions normally happen. Either we have no solution, or the outer intervals, or the inner intervals, or you have everything. Okay, so let's go ahead and test the interval in the center to see what happens there if we get a true or false statement. So let's see. We're going to test again. We're going to be using x equals 0 here. This should be easy. So we're plugging it into the same inequality, y squared minus 5y minus 14. So the question is 0 squared minus 5 times 0 minus 14, is it less than or equal to 0? Is it? If you simplify this, you have -14. Is -14 less than or equal to 0? Absolutely, this is true. Okay, so based on the pattern, we can expect this to be false. Okay, now just to verify, we're going to test using the test value, which is 8. Okay, so let's do that. X equals 8. We're going to plug it into this inequality and see if we end up with a true or false statement. Hopefully it's false. So is that less than or equal to 0? 8 squared is 64. 5 times 8 is 40. is that less than or equal to 0? 4t minus 14, negative 40 minus 14 is negative 54. Is that less than or equal to 0? Is 10 less than or equal to 0? That's a no-no. That's a false statement. Okay? So our answer is going to be interval 2. Okay? So we're going to graph it like this. Everywhere in between. So the question is, are the endpoints included in the solution region? Are the endpoints included? The answer is yes. How do we know? There is a line underneath the inequality, which means that you have to include the boundary values. Our answer is going to be negative 2, so less than or equal to y in this case, and y less than or equal to 7. Answer for number 16 is D. Okay, so I told you there's another way to do this. Method 2, this involves using the graph. It's much easier. Method 2, which is graph. Okay, so all you have to do is know the critical values and the opening of the graph, okay? Since a is greater than 0 for the standard form, the graph does what? The graph opens up. Okay? It's going to be opening up. The opening is really important. So all we do is sketch the graph and then use the inequality to help us answer it. So we sketch the graph. We have two critical values which are equivalent to the zeros. So graph 1 here, negative 2, and the other 7. Since the graph opens up, we just draw a general pattern as to what it looks like. So it looks something like that. Okay? So the inequality says, where is y squared minus 5y minus 14 less than or equal to 0? Where is it either equal to 0 or less? So it's going to be here, here, and everything beneath. So all we do is project that to the x-axis, and that will be the answer. So it's going to be this point right here, the intercepts, and everything in between projected to the x-axis will represent this region right here. Okay? If it were greater, we'll pick the outer part. But since it's less than, we're going to pick the inner, because that is where the graph is beneath the x-axis. So negative 2 less than or equal to y less than or equal to 7 is your answer, because over here the graph is less than or equal to 0. Alright, so that's another way to solve the problem. Alright, let's take a look at question 17. It says, which of the following is a factor of quantity a minus 1 squared minus b squared? So you have to remember the difference of squares factorization formula. So I'd like you to recall that if you have a squared minus b squared, it factors into what you get when you take the square root of the first and the last and express it as a sum or difference. So the factored form of a squared minus b squared is a plus b times a minus b. Okay? So we'll apply the same idea here. This is the difference of squares. The first term is a quantity, so we can still apply the same principle here. So we have a quantity a minus 1 squared, that's your first square, minus b squared. So to factor this, we'll just take the square root of the first term, which is a squared quantity, and the square root of the second term. And we'll express the roots as a sum and a difference. So we're going to have, what do we have here? We'll have square root of a minus 1 squared. The square root and the square cancels out, right? So we have a minus 1 plus b, okay, times a minus 1 again minus b. So we can rewrite it as, using the commutative property of addition, this can be written as a plus b minus 1. And then we can rewrite this as a minus b minus 1. Okay, so these are the factors. So the factors are a plus b minus 1 and a minus b minus 1. So which one do we have as the answer here? A plus b minus 1. Answer is option letter A. All right, let's take a look at question number 18. It says, consider the function f of x equals x squared minus 2x minus 48. A part, determine the roots of the function, show your work. So let's say we have f of x equals x squared minus 2x minus 48. So to find the roots is basically where the function is equal to 0. Okay, that's what roots mean. So let's write that down. The roots of a function are the x values where the function attains a value of 0. Okay? Alright, so let's go ahead and do it. We'll set f of x equal to 0. F of x is x squared minus 2x minus 48. Set that equal to 0. We're dealing with a quadratic trinomial here. So to solve this, we're going to use the x game. AC goes on top. AC is negative 48. And b goes on the bottom. Two numbers that multiply to give you 48 and add negative 48 and add to give you negative 2. Negative 8 and 6 works nicely here. So in this problem, a is equal to 1, as you can see here. So that means that there's no need to factor by grouping, okay? We can just jump straight to the factored state using these two numbers here. Okay, so let's go ahead and express it in its factored state. We're going to have x minus 8 times x plus 6 equals 0. Using the zero product property, we'll set both factors equal to 0 and then solve. Okay, if we solve the first one, we have x equals 8. If we solve the second one, we have x equals negative 6. So our roots are x equals 8 and negative 6. So that's the answer to question 18a. Now let's take a look at the b part. It says the vertex of g of x is the point 3, 30. Write the rule for g in vertex form. The assumption here, in order for us to do this problem, because there are infinite possibilities, the assumption here is that a is equal to 1. Okay? Alright, so let's do it. So for the b part, let's write it. Assuming that a is 1, a equals 1, we're going to write down the formula, okay? The formula for the vertex form for a quadratic is y equals a times x minus h square plus k, where hk is what? What is hk? It is the vertex, okay? In this problem, we've been given the vertex. The vertex is 330, okay? So if the vertex is 3, 30, what does that tell us about the values of h and k? It tells us that h is 3 and k is 30. Okay, and then we also know that a is 1 by assumption, so we just plug in all those values into our function, and we'll have the quadratic of g in vertex form as 1 comma x minus h, x minus 3 quantity square plus k, which is 30. Alrighty, so that's your answer for question number 18, part B. Now let's take a look at the last part. It says, explain how f of x is transformed to become g of x. So all we just have to look at here is the vertex. Okay, we'll look at the vertices of the two quadratics, and then we can determine how to move from f to g. So let's write down the steps. Step number 1 is to express both functions in vertex form. And then step 2 is to determine how to go from the vertex of the vertex of f to g. Okay? It's not going to be that complicated. Alright, so the nice thing about this problem is that g of x is already in vertex form. We just have to direct our attention to f of x, which is not in standard form, and we have to use the we can use the vertex form formula to do this, or we can use completing the square, whichever you like. I'm gonna use completing the square here, but you can also use the vertex formula. All we are comparing, remember, are the vertices of the two functions. So let's use completing the square just for a change. We are going to have to create an incomplete square, x squared minus 2x minus 48. And then we're going to go, let's see, it's 48, right? Yes, 48. All right, and then we're going to say, what can I add to this quantity in the parentheses in order to create a perfect square trinomial? So whatever I add in here, in order not to change the function, I have to subtract the same thing from the outside right here. Alrighty. Okay, so let's see. What is that value that completes the square? B is -2. So to find what completes the square, we're just going to do b over 2 square. Okay, so b over 2 is -1. When you square that, you get 1. So we're going to add 1 here and subtract 1 here so that they cancel each other out. Now let's factor this. You read the first and the last, bring down the middle sign, and that will give us g of x and f of x in standard form, which is x minus 1 quantity square minus 49. Okay, so that's f of x. So let's see, f of x is that, and then g of x is x minus 3 square plus 30. So we're going to go from the vertex of f to the vertex of g in order to determine what the transformations are. Okay, so let's write that down. So the transformation from f of x to g of x involves going from the vertex of f of x to that of g of x. Okay? Alright, so what's the vertex of f of x? The vertex of f of x is hk, remember? So it's going to be 1 comma 49. And then the vertex of g of x is hk here, so it's going to be positive 3 comma 30. Alright, so what's the transformation? Let's take a look at that. For the x's, you're going to go from 1 to 3. So what kind of shift is that? You're going to shift 3 units to the right. It's not 3 units. I'm sorry, it's 2 units, okay? When you're going from 1 to 3, that's a 2-unit shift. So you're going to shift 2 units to the right. And then for the y, we're going to be going from 49 down to 30, okay, because we're decreasing. So this one is going to be a shift. Let's see, if you subtract it, you're going to have 19. So shift 19 units down. That'll take you to the y coordinate of the vertex for g. So there goes our transformation. Okay, so let's write down the answer. The transformation from f of x to g of x involves shifting 2 units to the right and what? And 19 units down. So that will take you to the vertex of g of x. Alright, let's take a look at question 19. It says several values of the quadratic function f of x are given in the table. Question. The function g of x is given by g of x equals negative x minus 2 quantity squared plus 3. Which function has the greater maximum for which value of x? Okay, so we're answering 2 questions. Which one has a greater maximum? And at what value of x does that maximum occur? Alright, so let's take a look at the numerical representation first and see if we can determine the vertex from there, and also the opening based on the pattern of the output values. So one thing you want to note is that the axis of symmetry for quadratic functions goes through where? The axis of symmetry always goes through the vertex. Okay? So one cool thing we can exploit here is the fact that symmetry is exhibiting itself. If you look at negative 4 to 4, they're symmetric, right? They're equidistant from a central value. And we have exactly the same output values. So we see that there's symmetry happening there. So we can use that to predict exactly where the axis of symmetry is going to be. So can you see where the axis of symmetry is? We have negative 4 and 4. They have identical outputs. 1, 2, 3, 4. Put 0 right there. And then 1, 2, 3, 4. They have identical outputs. So that means that the axis of symmetry is going to be right down the middle. Okay, so for negative 4, let's say this value right here is negative 96 and this is negative 96. It's not drawn to scale by any means. Okay, so we have those 2 points on our quadratic function, and we know that our quadratic function has an axis of symmetry going right through the vertex. The axis of symmetry is going to be going through the middle of these 2 points. If you average these two, you get 0. So we know that the x-coordinate for the axis of symmetry is going to be 0. Okay? We just have to use the table to figure out the y-coordinates. So this is going to be your axis of symmetry. Axis of symmetry at x equals 0. Now, take a look at the table. We can easily determine what the y-coordinate of the axis of the vertex is, which is 0. Okay? So this is another point on the graph right here. And just following the pattern of the points, it's increasing and hits a maximum of 0, and then it starts to decrease back down again. Okay? So we can see what kind of extrema we have in this scenario. We have a maximum for f of x. So our vertex for what is this, f is 0, 0. So which basically means that the maximum for f of x occurs at x equals 0. So that's that. Now let's look at g of x. G of x is negative quantity x minus 2 squared plus 3. Now we just need to determine the vertex for this, because since it's negative, we know it's opening down. They both have maximum. So what's the vertex here? Because the y-coordinate of the vertex tells us the value of the maximum. Okay? So we have, to recall, let's just put a side note here. Recall that y vertex is the same thing as the y max or min, depending on the opening. In this case, it's going to be a maximum since it's downward opening. Formula for a quadratic in vertex form. What is the formula? A formula is y equals ax minus h squared plus k. So we can easily, okay, vertex, don't forget what the vertex is, where the vertex is hk. So we can see that h is 2, k is 3. So in this problem, our vertex is what? Our vertex is 2, 3. Okay. The y-coordinates basically tells us the maximum value for g. So g max, which is equal to the y-coordinate of the vertex, is 3. So let's compare them. F max is, what is F max? Oh boy, I didn't state it. F max is equal to 0 and G max is 3. So we need to compare them. Which is greater? G max has a greater maximum. Okay. So since G max, the maximum of G, is equal to 3, is greater than the maximum of f. What is the maximum of f? Is at 0, right? Is greater than the maximum of f, which is at 0. And this occurs at x equals, and wait, hold on. G max is at, where is G max at? Let's write that down. And G max is at what x value does this function attain its maximum? At the x coordinate of the vertex, right? G max is at x equals 3, x equals 2. Okay, it has a maximum value of 3 at x equals 2. So G max is at x equals 2. Since we have this condition, the answer is option letter C. Okay, so we just compare the y coordinates. Whichever one is bigger, that has a bigger maximum. and the x coordinate of that maximum will tell you where the maximum occurs at. So answer is option letter C. Alright, let's take a look at question number 20. It says, which statement best describes these two functions? So we have f of x and we have g of x. Now, if you look at the options right here, what we just have to determine is the nature of the extrema of those two functions and compare the value of their extremas. Okay? So do we have a max or min, and which is greater or less? That's basically it. Let's start with f of x. Now, let's deal with the extrema first. F of x is equal to 1x squared 1x squared minus x plus 4. So with this, we know that a is 1, b is negative 1, and c is positive 4. What's the opening of f? Since a is equal to 1, which is greater than 0 or positive, f of x opens where? If you have a positive a value, you have a happy situation, right? It opens up. F of x opens up, which means that f has a maximum or a minimum. This is a low point, right? So since the low point, f has a minimum. Okay? So that's the extrema of f. Okay. Now, what's the value though? What's the value of the minimum of f? F min is basically the function evaluated at the x coordinate of the vertex. Okay, which is the same thing as the y vertex. All right, so let's go ahead and figure that out. Start with the x coordinate of the vertex. That's negative b over 2a. So we have negative 1 over 2a. So minus minus becomes a plus. We have 1 over 2 as the x coordinate of our vertex. Alright, so now that we have the x coordinate of the vertex, how do we find the f mean or the y coordinate of the vertex? Do the same thing. To find f mean, we're just going to simply evaluate the function f of x at 1/2. Okay? So we're just plugging 1/2 into the function. We have 1/2 square minus 1/2 plus 4. Alright, let's go ahead and simplify this using the order of operations. 1/2 squared is 1/4 minus 1/2 plus 4. Express all of them as fractions. Find the LCD, which is 4. So we have 1 over 4. Times this by 2, top and bottom. Okay, that gives us minus 2 over 4. And 4, you times it by what? Times it by 4, top and bottom. And that gives us plus 16 over 4. The goal here is to get all the denominators identical so we can combine. Alright, 1 minus 2 is negative 1. Negative 1 plus 16 is 15 over 4. There goes your f min. Okay, so f min is 15 over 4. Proceeding to g. What's the story with g? What's the opening? Let's start with that first. G of x is the function negative 3x squared plus 3x plus 7, which basically tells us that a is negative 3, b is 3, and c is 7. Now, what can we say about a? Since the a value is negative 3, which is negative or less than 0, g of x does what? It opens down. It's sad. Okay, so we have this kind of opening here. So since we have it opening down, how will you describe the extrema of g? G has a maximum. okay, because this vertex here is a peak. Now, how do we find the value of that maximum so we can compare it to the minimum of f? Same procedure, okay? So Gmax is the same thing as the y-coordinate of the vertex, which is the function g evaluated at the x-coordinate of the vertex. So let's find the x-coordinate of the vertex for g first. X-coordinate of the vertex is negative b over 2a. So let's work this out. Negative b is 3 over 2a, a is negative 3. So we are going to have negative 3 over negative 6. When you simplify that, you have 1/2, okay? Now that we have the x-coordinate of the vertex for g, how do we find the y-coordinate of the vertex, or Gmax? Gmax is simply the function evaluated at the x-coordinate of the vertex, which is positive 1/2. So we're going to plug in 1/2 into g, okay? So we have negative 3 times 1/2 square plus 3 times 1/2 plus 7. Now, using the order of operations, we're going to have negative 3. 1/2 squared is a quarter, okay? Plus, put this as 3 over 1, multiply horizontally, 3 over 2 plus 7 over 1. This can be simplified further into negative 3 over 4 plus 3 over 2 plus 7 over 1. Now to combine these fractions, we just have to find the LCD of 4, 2, and 1. We already did this before. It's 4, right? So let's make all the denominators 4. This will times by 2 top and bottom. This one will times by 4. So that gives us negative 3 over 4 plus 6 over 4 plus 4 times 7 is 28 over 4. Denominators are all identical, so let's combine. Minus 3 plus 6 is positive 3. So we have positive 3 over 4 plus 28 over 4. And that gives us the final result of, what is it? 31 over 4. Bam. Okay, so that's our G maximum. So G max is equal to 31 over 4. Now, how does this compare with the other result we got, which is an F max value of, what is it, 15 over 4. So F max is 15 over 4. F min is 15 over 4. So we can clearly see that the minimum of f of x is less than the maximum of g of x. So that's our final answer. Okay, let's write that down. The minimum of f of x, which is equal to 15 over 4, is less than the maximum of g of x, which is 31 over 4. So that's your answer. Answer to question number 20 is the minimum of f of x is less than option B. There you go. Okay? Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming semester exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place it in the comment section below and we'll be more than glad to support you. Do not forget to subscribe to our channel. We always update math content to our YouTube page, so if you subscribe, you get notifications of those updates. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.